All right, chapter 14, part 3. This is actually going to be a little bit of a shorter video. I don't have that many slides left to go through with you. It's a short chapter. The rest of the chapter, we're going to be talking about human population and how rapidly human populations are growing right now. And in order to understand that, the first thing we're going to look at is something called the age pyramid. And age pyramids are just graphs that show population characteristics, including the country that we're talking about here. And on the side, we have the age range, and it's usually a 5-year span, so 0 to 4 or 5 to 9. These are 5-year age uh, groups. And then always the year and the population size, males and females. So we divide that up. Of course, remember from before that females live longer than males, and we can see that in the age pyramid. Some of the age pyramids actually look like pyramids, like the one we see here in Kenya, and some of them don't quite represent, they don't really look quite like a pyramid. So this one has this weird shape to it. And the thing about these graphs is that they tell us a huge amount of information about the population of those countries. So Norway is an industrialized country, and it's got more of a rectangular shape to it. Actually, if you look at the younger people in the age of the country, there's not as many young people being born. Their actually population is on a decline. So you can see that Norway's population is shrinking because not as many babies are being born. We also see something interesting here. We've got this big bulge right here from people aged mostly like 40s through their 60s, and that is the baby boom. So what happened after World War II is called the baby boom, and they had lots and lots and lots of babies. There was this little kind of reflex, and then there was a little bit more babies being born after, I guess, kind of the baby, they call it the baby bubble or the baby bust. So one of the things that you can see here in Norway is that that the rate of decline, the rate of death, is actually low, even though everybody dies, right? That happens. But the speed at which they're dying is much slower in Norway than it is in a developing country like Kenya. So Kenya has a more of a classic population pyramid. This is the kind of pyramid that we see in all developing countries. It's the kind of pyramid that we would see, a couple of hundred years ago before the Industrial Revolution. Some other major differences comparing Kenya and Norway is that Kenya, babies are still being born at a really high rate as opposed to Kenya where it's declining. You can see that decline by going kind of backwards there. But here we're still expanding out. You can also see that the population size, these are just in terms of thousands of people. So this is 50,000, 100,000. But this is talking about 1 million people, 2 million people. So the scale is a little different. But one thing that we do see here is that mortality rates are very high. That's this very steep decline here that we see as they get older. And there's not a lot of old people in Kenya. You're not seeing a lot of people over age 80 in Kenya and other developing countries. So what does it look like in the United States? This is showing a population age pyramid for the United States over quite some time in the 1980s versus 2010s. And what we see here is, looking here at the top, we see this more of a classic pyramid shape, and then it squares off. And then, and one of the reasons it's squaring off here is because of World War II, just so you know, where lots of people died. But then we had all these babies being born after World War II, so we have the baby boom. And then what we see here is as our population is aging, you'll notice that we have more of a rectangular age pyramid, which means that population size is staying fairly steady for the United States. But our baby boomers are aging. And because we don't have a lot of young people helping to pay into the retirement system or social security system for the older people, this is going to become a little bit of a problem for us. We have to figure out how to safely take care of our elders and make sure that they're not living in poverty as they age. And but we don't have a lot of new people being born into the population in order for us to support them in a very easy fashion. So that's one interesting thing. I have this other interesting thing here. This is world population size. This is a GIF. We're just going to watch this over time. Sorry, got a little commercial there. Need to get rid of. We're watching this over time. This is the time scale. It goes from 1950s through 2000s, and it's projecting into the future of what population is going to be like around the world. So that's what this is showing you. It's showing you where we are. And one of the things that you're noticing is that some of these countries are ballooning up. This is representing the population size that's moving up. It's starting over right now. So this is kind of what it was like in the 1950s. We've got a lot of population in the United States and Europe. But we see Europe shrinking, and that's what we see happening in Europe. This is India. We see India's population growing. This is China, which is population is shrinking. And this is the continent of Africa, and we see that Africa's population is projected to be increasing quite substantially into the future. So, and this has to do with industrialization. Remember that industrialized countries, people don't have as many babies. Again, starting back in the 1950s here, people don't have as many babies. As we go through industrialization, the population tends to get larger and larger and larger. I'm going to explain why that's true on the next slide, but for now, I think it's interesting to kind of see where the population is going to be projected to be growing around the globe, shrinking in the Americas and in Europe, growing in the continent of Africa, and especially here in Southeast Asia. As China shrinks, this is Russia up here. It's got a pretty small population size. This is Japan. Down here is Australia. So just kind of getting a little picture here of what the future holds for humans in the world. Okay, so I'm going to minimize that now, and I'm going to go back to my lecture, and I'm going to give you a little bit of information about what was causing those differences in population growth around the globe. And again, as I said before, it has to do with industrialization. So, and the term for today on this slide is demographic transition. So the demographic transition talks about how as non-industrialized or developing countries become industrialized, what happens to their population size? And there's 3 lines on this graph. This is probably the most complicated graph of all the graphs that we're looking at today. There's 3 lines on it. You have to keep track of all 3 of them. So the first line that we're going to look at is the birth rate. And what this is saying is that over time, the birth rate of industrialized countries stays high for a really long time. As they're becoming more and more and more industrialized, cultural influences maintain that people want to have large family sizes, and so their birth rate stays high. Eventually, though, we see this repeatedly over and over again, that birth rate declines, and it'll decline fairly rapidly until it goes back to being stable, but at a much lower level. So that's what happens to birth rate as we go through this demographic transition, as we transition into an industrialized country from being a non-industrialized or developing country. But what happens to the death rate? That's interesting, because the death rate in those non-industrialized countries is pretty high. It's almost as high as the birth rate, which means that the population size in those countries is staying stable. Remember, we talked about stable population growth back in one of the first slides in this series for chapter 14. So, but as countries industrialize, they start to get modern medicine. And with modern medicine, that causes the death rate to decline really fast. And it goes down really, really sharply to the point where to the point where their death rates are going to be really low, even though their birth rates are really high, really quite still high. So when they're in time early on, that when the birth rates equal the death rate, the population growth is not very high at all. It's fairly stable. But as death rates start to decline, the population growth rate becomes more and more positive. Remember when we were talking about growth rate, we said growth rate can be positive, growth rate can be negative, or it can be stable. And in this instance, right here, where death rates are declining but birth rates are high, the population is growing, and it's growing exponentially. It's growing very rapidly. So that growth rate will reach a peak. And when it reaches this peak, that's when the birth rates are the highest and the death rates are the lowest. This gap between here and here, that's an extremely high positive growth rate. As the industrialization process continues, the demographic transition continues. And this decline in population growth rate does not mean that the population is getting smaller. It just means that the growth is slowing. So this is not a negative growth rate. I need you to understand that. It's not below the line here. If it was below the line, it would be a decline in population. This is just a slowing down of the growth. The birth rate is slowing down. The death rate is staying low. And so if people are having fewer babies, the population is still growing, but not growing as fast. So this is stage 2, called fast growth transitioning into a period of slow growth. Here in time, we have full industrialization, and full industrialization with low birth rates and low death rates, meaning you have slow growth. We had slow growth here with high birth rates and high death rates. We have slow growth here with low birth rates and low death rates. But in the middle, when we're going through this transition, when culture still has a big influence on how many babies people are having, we have fast growth rate. That is the demographic transition, going from non-industrialized over time, industrializing into fully industrialized. That's the pattern that we see over and over and over again. It's the pattern that we had in the United States, and it's the pattern that we saw in every single industrialized country. They went through their own demographic transition. If we're wondering why Africa and India are about to go through these huge growth rates, it's because they are starting to be industrialized. And that's a good thing. Industrialization brings medicine. It means people survive in a much, much healthier way. And so we hope for that. But it does give us a bit of a problem because we run through an issue of resources, right? Is there enough food to go around and so forth? Again, tying back to some of the slides that we said earlier. You might ask, how high can human population grow? And we are currently above 7 billion people on this planet. That is a very new thing. For the last 150 years, we have been going through a period of exponential growth, starting in Europe and especially United States and Canada, and then that transitioning over to other countries like Eastern Europe, China, Asia, South America, and so forth, and then finally finishing up with Africa and Southeast Asia. So eventually, though, and this is the problem, is that there's not going to be enough resources to go around. I mean, there's only so much land that you can grow food on, right? So, so we are currently adding about 80 million people to the world every year. And if you look back in human history, and we've been able to do this through archaeology and so forth, we didn't always have such a large population. For the vast majority of human history, the last 10,000 years or so, which is not all of human history, but it's a major part of our after we kind of invented what am I saying, agriculture, that kind of thing. Our populations were pretty low. We were talking well under 1 billion people humans on the planet for a really long stretch of time. These little blips that you see of increasing, those are exponential growth blips right there. And you see like kind of a little bit there, then you see kind of a slow, steady increase. And what you're seeing with these little blips or these slow, steady increases are minor increases in technology, maybe going through artificial selection on cattle and things along those lines, maybe a till, those kinds of things. You see this little blip right here of a decrease in the population. That is the Black Plague, like we talked about earlier. But then shortly after that, we see exponential growth again, and then we hit the Industrial Revolution. And when I say industrializing, I'm talking about what happened with the Industrial Revolution. And we see that really, really crazy increase in human population on the planet. How high can we go? I don't know. Some people think we're already at kind of close to carrying capacity. If we are, that's not good news. Some people think that maybe we can reach 11 billion people and still be okay without having food shortages all over the place. I mean, the rate at which things are going, we're going to hit 11 billion people probably before you die. So that's kind of important to think about. How do we deal with this kind of thing that is carrying capacity? And there's a few solutions, um, but again, one of the reasons it's so hard for us to estimate what the carrying capacity is because we have continuously been able to increase our carrying capacity over time. So we could continue to do that in several of three ways. So we could expand into new habitats. This is Dubai, which is in the United Arab Emirates, which is basically a desert. And there's this huge city in the desert. Um, if you've got shelter, you got climate control, we can survive pretty much anywhere. If you got food, you can survive pretty much anywhere on this planet. So we could start to live in places that maybe we haven't lived in the past. We can increase agricultural productivity of the land by using fertilizers and machinery and so forth. And this has really helped us over the last 100 years. This fertilizers and machinery and lots and lots of yields on food. I'm not sure that we can do much better than we're doing now. I mean, let's think about it. With our population growing, where are people moving to? Like, if you think about it, where are the new subdivisions going? And a lot of them are going on old agricultural fields. So some of that good prime arable agricultural land is actually not doing so well. So I'm not sure that we're going to be able to increase our agricultural productivity. I don't know. The next one, and I think this is probably one that we'll settle on, is that we could find ways to live at higher densities. So living in cities is going to be the way that we're going to be able to have enough arable land in order to feed all the people that we have. Some people don't like the idea of living in cities in high density, but if we're going to keep having babies at the rate that we are, then this is going to have to be one of the solutions. So that's important. How high can we go? Again, this is very, very difficult to answer this question. But one of the things that's really limiting how high we can go is something called an ecological footprint. And an ecological footprint is an evaluation of how much land, how much food, how much water, how much fuel, all these other things that you use in your own life that is used to support the lifestyle that you maintain. And so I actually am going to make this website that you see right here, myfootprint.org. That's going to be an extra credit assignment, and you'll be able to read about that on the post on Blackboard. I haven't set the due date yet, so stand by. But if you go to myfootprint.org and you write down everything. Don't do it yet because you need to see the instructions, and that's not yet posted on Blackboard. Stand by. Then you can earn up to 5 extra credit points, just so that you can kind of get a feeling for how your own behaviors affects how high our population can go. It's a kind of a big deal. I hope everybody does this. So that's actually all that I have at this time. I told you this one was going to be a little short, and I hope you enjoyed learning about populations.